Hi, my name is Carly Stanton, and this is my summary of the 4 articles that I reviewed this semester. So the articles I reviewed cover GIS use in various aspects of the oil and gas industry. The first article is a participatory GIS used to identify well locations in the Marcellus Shale. The second is about mapping oil and gas field boundaries and quantifying reserves on federal land in the United States. The third covers the use of remote sensing and assessing the likelihood of seismic activity on oil fields in the mountains of Iran. And the fourth is an analysis of the environmental impact of Bolivia's oil and gas industry on the local ecosystem. So the first article is called a participatory GIS utilizing the GeoWeb 2.0, filling the gaps of the Marcellus Shale natural gas industry. It focuses on the implementation of fractracker.org, which is a website that compiles spatial information on sites of hydraulic fracturing across the country. The need for FracTracker arose out of the inadequacy of readily available public data from the Pennsylvania Department of Environmental Protection. Location-based data collected for FracTracker includes drilling sites, roads, topography, and population density. The information on FracTracker gives a good representation of the potential costs and benefits of hydraulic fracturing to the state of Pennsylvania in such areas as the environment, public health, local economies, and air and water quality in the affected regions. This article provides a good understanding of the successes of fractracker.org and the usefulness of a participatory GIS, as well as the issues of inaccuracy that can come with any crowdsourcing project. The title of the second article is GIS Automated Oil and Gas Field Boundaries. It evaluates the Energy Information Administration's methods of mapping oil and gas field boundaries for 12 onshore study areas in the U.S. These areas were mapped to estimate what portion of proven oil and gas reserves are located on federal lands. This required adapting existing public source boundaries to get a more accurate view of the actual locations of oil and gas reserves and then intersecting these with federal land coverages. The EIA obtained pre-existing boundaries, which were mainly authored by state geological surveys or oil and gas commissions. These were classified as hand-drawn boundaries with smooth borders, boundaries based on buffered wells with scallop borders, or boundaries based on land or legal units with rectilinear borders. The boundaries were adapted by buffering the wells, unioning the well buffers, and applying an algorithm to smooth the boundaries. I thought the authors of this article provided a thorough description of the reasoning behind the EIA's decision to use these methods to rectify any inconsistencies in the pre-existing data. They also illustrated examples of techniques used and presented a list of guidelines for adapting the data in each technique described. The third article is titled Use of Remote Sensing Data and GIS Tools for Seismic Hazard Assessment for Shallow Oil Fields and its Impact on the Settlements at Masjid-e-Soliman area in the Zagros Mountains of Iran. It uses remote sensing to analyze the potential for seismic activity and earthquakes in the mountains of Iran and to assess the possible effect of this activity on the shallow oil fields of the MIS area. The author's methodology contains 3 steps, the first of which is processing of Landsat satellite imagery and field investigations for distinguishing structural features. The second is investigation of recent fault activities by a seismotectonics assessment. And the third, a digitizing of an underground contour map and preparation of a 3D sketch showing the relationship between surface and subsurface structures. The information allowed the authors to produce the underground contour map and identify areas which had the highest likelihood of activity and what communities that activity might affect. I felt that the authors conducted a thorough study which allowed a fairly accurate portrayal of the area's structure geology. They used multiple data sources and combined these to create a more precise map. The final article I reviewed is called A GIS Approach to Ecosystem Services and Rural Territorial Dynamics Applied to the Case of the Gas Industry in Bolivia. It analyzes the environmental impact of the gas industry in 2 mineral-rich territories in Bolivia using a GIS approach. The study also compares its findings with the public perception of environmental change due to extractive activities. In this analysis, the researchers first gathered their information on certain indicators like land slope, temperature, and biomass density for the areas involved. The sources for that information include satellite imagery, DEMs, and meteorological data. These indicators serve to quantify the environmental factors that determine an area's rural territorial dynamics. These factors include water availability, erosion regulation, and natural diversity. The data was analyzed for the years 2001 and 2008, and these factors were weighted, aggregated, and compared for those years. Maps of environmental change in these regions were then created, which showed little to no significant impact over the time of the study. These maps were compared to locals' perceptions that the environment had significantly deteriorated due to drilling practices. I felt that the researchers did a good job of presenting a quantitative approach to a sensitive issue for many people in the region. However, the maps, I felt, underemphasized the actual value ranges for deterioration and the improvement of environmental factors. Also, I thought that the deterioration of certain areas was too readily dismissed. So that concludes my summary. I hope the articles I reviewed provided a good picture of just how many applications GIS has in the oil and gas industry.